Hey guys, welcome back. So today, continuing work on the Chicago electric generator. In the last video, we spent mostly troubleshooting why it wasn't making power, and it turned out that it was a bad rotor. It does have a ground fault, so because of that, this generator won't power up, but we do have a good engine and a frame and a tank that's more or less intact. Now, I do have another Powerhead I can put on here. It is rated also at 5,500 watts, just like the bad one, but it is a brand new Ryobi Powerhead and cost me about $200. So it's not my first choice to put it on this frame. The tank's not in great shape. There's a lot of sun fading and rust, not to mention the control panel has been modified a bit. So this frame, it is an option, and I might have to use it because the frame that I want to put it on is this Predator frame. It's in very good shape. It has a good tank, and it even has a wheel kit. But the rails, they are about an inch further apart than on this frame. So in order to get this generator and the new Powerhead on here, I need to relocate the engine mounts and the stator mounts, but I'm not sure I have enough room to make everything fit. So I think that is the best place to start. I'm actually going to get the wheel kit on first. We'll relocate the engine and the stator mounts and then start installing things and see if we can get that to work on this frame, which hopefully it does. Otherwise, we'll resort to plan B, which is using this frame. So let me get you set up a little bit better and get going on this. By putting that on, I now have access to the bottom of the rails, so it'll make drilling through easier as well as securing everything in place. I'm going to leave the handle off for now because it's just going to interfere with what I need to do down below. And to that end, I'm also going to pull this control panel off. It's kind of in the way. More importantly, I do need to modify it later, assuming all this installs without issue, because the original Powerhead was rated at 7,250 watts, and the circuit breakers are sized appropriately at 30 amps each. The new Powerhead, it does need 25 amp circuit breakers, so I do need to open up that control panel at some point and swap those out. Going to start on the engine side and relocate these mounts. And you can see there's not a lot of space here because I can't move it all the way up to the edge, because if I do, then this nut will never tighten up. It'll hit the side here. So I think the best I can do is move the hole over about 1/2 inch. And that's about it. I can do that on both sides, both on the engine side and the stator side, and that'll give me about 1 inch total. And I actually need a little more than that. But the mounts, they are flexible, and I might even be able to turn it slightly to make up the difference. At least that's my hope. So yeah, let's just relocate these. We'll get the engine in place, drop the power head in, and see if it has any chance. Yeah, I think that'll work. The mounts, they've all been relocated, and I left the stator side ones kind of loose. So I won't tighten those up until everything's installed. So really the only thing to do now is to drop the engine in place. We'll tighten that down, get the power head installed, and see, I guess first off, will things mount properly onto this frame as far as the engine and the stator goes. The second issue is going to have to do with the exhaust, because the existing mounts may not line up, and I know the exhaust is going to be a little bit too long and it's not going to secure properly to the stator, but I think with a couple spacers that should correct that issue. So let's find out. The new stator, it's a little longer than I thought it was, and that's good. That's only going to help. I thought it was 5 inches, but it's actually closer to 5 1/8. So that should be good. The new rotor, I've already test fit it. It fits fine on that tapered shaft with no interference. So let's get the rotor installed. I'll torque it down to about 30 foot-pounds and then move on to that stator. I need to torque that rotor down to 30 foot-pounds. So in order to do that, the engine has to be locked up. The easiest way to do that is to just pull that starter recoil off and get a wrench on that nut to hold the engine still. To get the end housing on, the important thing is just to line up these wires here where they need to go. This plug is for the AVR, which usually exits right here. And these are the wires for leg 1 and leg 2, supplying power from the stator, which runs up to the outlets. So those ultimately need to connect to this wire block right here. So we'll just get this in place. And I stole these bolts from the other stator. They're not absolutely necessary, but the stator does have a hole drilled through it. So you can use that to kind of line things up the way they're meant to be. If you don't have this, you can still install it without it, but it makes it a lot easier to install this power head, and it also lines everything up the way it's supposed to be. So we'll drop both of these in. Potentially they're a little bit too long, so I might have to cut them down, but let's try it like this and see how it works. Well, it looks like it worked out. at least as far as the engine and the stator mounts go. It is now secured to the frame. So before proceeding, now is a good time to pull the engine over just to make sure that the alignment is good and that the rotor is not making any contact with that stator, because if the alignment's off, then the power head is going to burn itself up pretty quick. So I need to get that starter recoil back on. I do have the spark plug removed, so the compression won't be fighting me. And before I do any of that, I'm actually going to put some oil in the engine. Right now it is empty. So we'll get that stuff squared away, pull the engine over, and make sure that everything is good. Perfect. Sounds good. So we get this bracket installed. This is what holds the exhaust on the stator side. And because the stator is smaller, the exhaust, it'll be too long by about ½ inch, which isn't a big deal because if it passes the bracket a little bit, I'll just use a spacer on the back side to take up that gap. I think we're going to be okay. The bolt holes for the heat shield seem to line up, more or less. And as expected, where this bracket is, we are about ½ inch away. So I just need to get a bolt or two as a spacer, and I think we'll be good. I think we passed the hurdles that I was worried about. We've got everything bolted down to the frame. The exhaust went on without issues. So we're pretty much home free. Really, the only thing left is to reconnect this cooling tin on top of the head. And mechanically, I think we'll be in pretty good shape. Really, electrical is what's left. So before I put that plate back on, I'm going to just pull the airbox off. We'll pull off this blower housing. I have a Predator blower housing that I think will fit. And of course, will match the generator a lot better. This does indicate it's a 420cc engine, which is what this is. And both these engines are Harbor Freight engines. The Chicago Electric brand, I'm not sure if it just predates the Predator branding, but it is essentially the same thing. So we'll swap that out, get it to match a little bit better, finish up with that plate, and then move on to the electrical. We're not going to use that for a fuel clamp. So we'll take that off. Just going to attach the wiring for the fuel solenoid just to get it out of the way. The new Powerhead actually does not have the auxiliary winding to power this fuel solenoid, which is not an issue because these are normally open. The only time they close is when you shut the ignition switch off, it energizes just until the engine spins down and then it opens back up. But it's usually not needed. It does make restarting a little easier so the engine doesn't flood, but in this case, it won't be used. Unfortunately, the seal is shot on this airbox, so I do have other airboxes. Let me see if I have anything like this. So this is from a Honda clone. It's actually from a Predator, and so is this one. They're not compatible, though, with the airbox that's on there, so I would have to uninstall the airbox and put this entire one on, which isn't a big deal, but I think I have another which is more compatible. So let's take a look at this one. And this one, I believe, is exactly the same. The biggest difference really is that there's no entrance to this box for the tank vent, but I think I can just steal the parts I need, which I'll probably take this front part since it looks better, but more importantly, it has this part that has a good seal. So that most likely will fit. So let's find out. Perfect. Foam filters, they do need a bit of oil to work properly. So just apply a bit of motor oil and then squeeze the filter to kind of work it all in, and then use a towel to get rid of the excess. I ended up switching back to the original cover because the one that I put on there, although it latched in place and it seemed to be a good fit, it didn't latch very tightly like the original one. So despite its sun-faded look, I think it's a better cover for the airbox. So a little bit of WD-40 will definitely improve the appearance of this a bit. So I'm gonna open up this control panel and steal those circuit breakers. It's already mostly opened up. I think only the screws in each corner here are holding this back piece on. So we'll get those screws out and we should be able to harvest those circuit breakers. And it's these two here that I'm after. So we just get those unplugged. going to swap these out one at a time so I don't mix up any wires. Now these are a little different because they are attached with a screw, so I don't know if this is going to be compatible with the circuit breakers I just pulled out. So I'll start with the bottom one here and see if we can make the other circuit breaker work. It's actually kind of nice that they screw these on. Usually they just push on, and those connections are not nearly as good, but that's usually what I see. I've been checking all the control panels I have, and unfortunately, all of them have these circuit breakers that are like this, that use the push connector rather than these screw terminals here. So I do actually prefer this type of circuit breaker, but I don't have any, and to order one, looks like most places are going to take a week to ship. So I think I'm going to just modify these 25 amp ones that I already have. And I've actually modified this one already. If you look at the terminal on the right, it's drilled out slightly larger, and that's going to let me get a M5 bolt in there. And with a little bit of Loctite, it should hold it in place. So I'm going to drill out the other side. We'll get this circuit breaker installed and then do the same for the other. This is where it gets interesting. We have the Predator harness, which was not designed for this engine. So not everything's going to match, and maybe not everything is going to be used. So I'm going to start with the low oil module. This is pretty standard. It's a yellow wire coming out of the engine. that is the oil switch going into the oil module. And the module provides a delay when the engine shuts down. And once it starts the shutdown, this kind of latches it in place to make sure there's a clean shutdown. So the black wire gets connected to the ignition coil. But the Predator control panel, it does have a low oil light. And for that to work, I think I need to use the Predator module. It has the same yellow and black wires, but there's also a red one, which is what supplies power up to that oil light and connects to this red wire here. So let's start just by swapping that out and connecting up those wires. And next we need to find which wire kills the spark from the switch up above. So I'm going to connect one wire to ground. We'll switch this to read continuity, so it'll beep when we have a connection. And right now the ignition switch is set to on, but when we turn it off, it should beep. And I'm guessing it's going to be the black wire coming down. So let's turn the switch off. And we get a connection. So this does need to be connected to the coil. So we'll connect maybe. All right, this boot is ripped, so I'll swap it out. That should do it. The oil module is connected into here, and so is the switch, and that combines these two ground signals to the coil, and either one can now shut the engine down. The brown wire coming down from the control panel is usually the charging circuit, and that accepts the input from the coil behind the flywheel, which I believe this generator has right here. So those should be connected together, but just to make sure, we can probably double check that. So I'm going to switch this to do a diode test, because this is AC power coming from the engine, and it goes up to the control panel and then should come down as DC, most likely on this wire. It's white, and that would connect probably over to here, which is the positive that runs to the battery. So when the engine's running, the power AC would go up the brown, get rectified to DC, and then send that power down here back into the battery. So it's in diode setting right now. We'll connect one lead to the brown wire and the other to the white. And if there's a diode in there, we should see a voltage drop, which we don't. So let's reverse these. Now we see a voltage drop. So that is the charge circuit. So we'll connect that to the brown coming out of the engine. Like that. And this one will connect over there, but this is a whole other problem. I'll get to that in a minute, so I'm not going to connect that yet. The two green wires coming down, those are for the fuel solenoid, which is not going to be powered. The new Powerhead does not have that auxiliary winding, and we can test that. These are the auxiliary windings right here. The one with the smaller wires is most likely for the fuel solenoid, and the larger wires are probably for the DC out on the control panel. So I'm going to leave this in diode mode, and we'll connect one. Actually, let me shut the ignition switch off, because that's the only time the fuel solenoid should be powered. We'll go from one of these terminals over to the green. No voltage drop. Let's try it the other way. Yeah, and we get the voltage drop. So that coil is what's for the solenoid. I'll connect those anyway, just so we don't have loose wires hanging around, but it's not going to actually do anything. Okay, and then this other auxiliary winding should be for the DC out on the control panel. So let's double check that just to make sure. And I'll put the other probe in the DC output on the control panel and see if we get a voltage drop. And we do. So we know what those are. They're not going to be used. Let's see, what do we have left? We have black wire with a white stripe. And we have this connector right here. So this one I need to research a little bit more. This actually goes to the low oil light as well. So I'm thinking that this is a ground connection, and most likely gets connected here. But I want to double check that before making that connection, but I'm pretty certain of that. And then this here is the problem. This on the Predator connects to the starter solenoid, and this one's very different. One of these wires coming down is a full-time power. So if I set this to continuity and I put a probe on this white one, which will be connected to battery positive, then I come down here. I think it's the black wire with the white stripe. Nope, it's the black wire. So the black wire is a full-time positive. Right now the engine's off, and that is energized, which is a little interesting. The other wire should be a switched ground. So if I put this on a ground, and the other one on black with the white stripe, we get no connection. I'm going to hit the start button. I just clicked it 3 times, and it sent a ground down to here. And that's where the problem is, because this is expecting a switched positive, not a switched negative. It's actually picking up negative from the block. So if I were to just connect the positive to the terminal here and then connect the battery, this would just crank the engine endlessly. It would not stop. And I guess I can show you that just by testing continuity from ground to the body of the solenoid. Maybe engine ground. Yeah, that's maybe not the best example. Let me get a battery and show you what I'm talking about. So we've got the battery here. I'm going to connect this alligator clip to positive. We'll touch or hold this to negative. And when I touch this on the tab up there, it'll trip the solenoid. So that's positive switched, not negative switched. So I think what I have to do here is to pull this solenoid off and put the Predator one in its place, which should solve that issue, because the Predator starter solenoid has this connector and it's expecting the ground to be switched. And assuming it fits, that should solve the issue. So let's try to get this off and we'll put the Predator one in its place. The wire I'm connecting now, that is the one that goes to the starter motor. And the one that goes to the battery is on this side. And it's not until the solenoid is energized, which energizes a magnet connecting these two sides, allowing the power to flow into that starter. And we'll just plug this into that. I forgot to connect up the white wire that comes down from the control panel, which sends power to the battery to charge it. All right, let's see if we get sparks. No sparks, but cable's a little short. I wonder if I should have got a battery that had positive on that side. I suppose I can just mount it that way. Well, no smoke, so that's a good thing. Let's try turning it over. And we get nothing. Why is that? Hey, you know what? I think it picks up the ground from the high voltage side of things. So let's just put this loosely against ground. Easier said than done. Here, let's use this. And the other end, maybe right here. Let's try it now. Nice. I don't have the proper tie down for this battery, so for now I'm just going to use a Velcro strap. It'll hold it in place, not too well, but good enough that it won't fall out of the generator. We're in the home stretch here. Really, we just need to hook up all the wires here, and we should be ready to test, but you can't just make assumptions as far as what's what. I mean, things are color-coded, but it doesn't always make sense, or it's not always what you think it should be. You know, in this case, I would say, you know, we have 5 wires coming down from the control panel, and we have the 2 auxiliary windings, which we know we're not going to use. This one is white with a green stripe. Most likely that's ground. We have 2 white. Those are probably neutral, and a red and a black, and most likely that's leg 1 and leg 2. But let's just probe it to make sure. So I've got the multimeter set to measure continuity. I'm going to put 1 lead in the 240 volt outlet on the ground and just make sure that this is the ground wire. And that is the ground wire. Let's double check the white wires to see if it's bonded neutral to ground. And it is. So we know that this is a bonded generator. And if you're going to connect it to your house, you do need to break that bond. But if you're going to use it as a portable generator, that's fine. A lot of times, too, the bond isn't actually in the control panel. It's usually down in the power head where it connects the white neutral literally to ground on the end housing. But in this case, it's taken care of, so we don't need that. We actually don't need to test neutral because all 3 of these wires are essentially connected together. So let's move the probe over to one of the legs and just make sure that the black or the red wire makes the connection and nothing else. We'll check the red. We get a connection. Black, nothing. We'll check the others just to make sure. And only one connection, which was to the red. So let's move the probe to the other leg and make sure that it's only the black. Black has a connection, and none of the other wires do. So good, we got our bearings as far as these wires go. Now the stator has 3 wires coming out. The old stator had 4, and that's not an issue really because it can be done either way. Leg 1 and leg 2 should each have 2 wires, a neutral and a live, and a neutral and a live. In this case, they commoned up or combined the neutral into 1 wire. And I can tell from looking at this that this wire most likely is the neutral because it's white and the other wires are black. But let's just double check that with an ohms test. Hopefully you can see that multimeter. I'm going to set it to measure ohms. And what I'm looking for is that from the white wire to either of the black wires, we should see a consistent value of about 0.3 ohms. And if I go from the black wire to the black wire, we should see double that because it's going through both leg 1 and leg 2. So I'll put one probe on the white wire and just pick one of the black wires. And we're at 0.4 ohms. And my leads have a 0.1 ohm resistance. So the actual reading is 0.3. So that's good. Let's check the other leg. It should be the same reading, the 0.4. And it is. Now if I go from black wire to black wire, it's going to be roughly double that, 0.8. And that's what we get. So we have our bearings. All we need to do is connect the wires up, install the brushes and the AVR, and we should be good to go. I threw a new set of brushes in there. The old ones weren't that bad, but I do have a bunch of new ones and they're dirt cheap. So we'll use those instead of the old ones. And I'm also going to try this AVR. It is brand new. It was sent to me by a subscriber. So yeah, let's get this connected, being sure to connect the positive wire to the left terminal. Got the spark plug reinstalled. I double checked the gap too. It was too small. It was actually less than 20 thousandths of an inch. It should be closer to 30. And I'm just filling the bowl now with some fuel. We'll give it a quick test. So what do you think? Is it going to work? I hope so. Not too bad. We got power. A little low, it was around 115 volts, and the engine speed was a little slow as well, but that I'm not going to adjust yet. I want to run it longer, let it warm up, because the speed will come up a bit as the engine warms, so I don't want to adjust it quite yet. But the voltage I can adjust now, so I'm going to pop that AVR off. I'm going to turn that potentiometer about 2 turns clockwise. Usually a full turn is about 2 volts, but not always. So just keep that in mind. After you make that adjustment, check the voltage again and make further adjustments based on what you see. This blue rectangle here, this is the potentiometer, and there's a little screw hiding under this blob of red. I'm not sure why they're trying to hide it. Usually that's not the case, but I should be able to scrape that off with any luck and make that adjustment. Don't even have to scrape it off. There's one. And that's 2. So I'm going to let that dangle. We'll start it again, see where the voltage is at. That was perfect, right at 120 volts. So, there's not much left to do other than get the tank on and maybe figure out where this last wire goes for the low oil light. And yeah, we'll get this outside and do some load tests. Actually, I think I'm going to get the end cap on the Powerhead. I'm pretty sure I'm done in here. So before I can put the cover on, I do need to secure these wires so they don't get sucked in to the Powerhead and destroy it. And same with these here. So I use these specialty zip ties that have a hole for a bolt to hold it in place. We'll deal with this one later. I don't want to pull this label off, obviously, because it has a lot of important information on it, but I don't want it to be misleading either. So most likely, I'll have to print something up, some sort of a sticker, to put the correct wattage on there. And similar here, these are 25 amps now, not 30. I was able to locate a wiring diagram online and confirm that this wire coming down from the low oil light does connect right there. So that should be all set. As far as the battery goes, it's held in there by the Velcro, but you can see it's not held in there very well. It slides around quite a bit. So I did call Harbor Freight to see if I could get the proper hardware to hold this in, and of course they don't have it. It's not available. So I can make something with some J-hooks and some angle iron, and I might come to that, but I'm going to stick with the Velcro strap for now. It's a lot easier to deal with. And I think if I add a strap going around down here, it'll help hold it on to the backer and also put one on top. That'll definitely hold it in, but I guess before I do that, I do have some self-adhesive foam that I'm going to put to the bottom of the tray, the back, and the top of the battery where the strap goes. And I think that might provide enough friction to keep it still without adding another strap. Yeah, I think that'll do it. As far as this label goes, I've been working on a prototype and just printed a draft on a piece of paper just to make sure the sizing is correct. And we're pretty close. I'd say it's a little bit short, it needs to be a touch longer, and it might be just a little bit too tall. But otherwise, I'm pretty happy with the way it's turning out. But I did make a mistake here. This Powerhead, it's actually rated at a max of 6,875 watts. So that's an easy change. So I'll keep working at this. Once I get it perfect, I'm going to order up a weatherproof sticker and attach it permanently. When putting the line on the rollover valve, I noticed a pretty serious issue. The valve, it's quite loose. And most likely if the tank is filled up and the engine running, this is gonna leak, which isn't great. And whoever designed this tank really didn't give it much thought, because this valve in any other spot would have been better. But right here, it's above the exhaust, which is the hottest part of the engine. So you don't want fuel leaking out right here onto the exhaust, because it's gonna burn the generator to the ground. So I tried fitting in this brand new Generac rollover valve, and this one's even worse. It's looser than that one. So I called Harbor Freight, tried to order the exact part, and they told me they don't have these parts. I can't get it from them, and to try a generic part, because they are common as far as the sizing goes, but that's not going to work. So this has to be fixed, or I'm going to need a new tank to make this safe. So there's a couple options here. I guess the first one I was thinking is that I could use a piece of shrink tubing and put it on like that shrink it down and see if it'll fit in snug. But I actually think it's going to make it too thick. But I think that's worth a try, so I'll try that first. If that fails, then I think just a little bit of JB Weld right along here to glue the valve to the top of the tank. So that way, any fuel that leaks past this rubber seal will be stopped, hopefully by the JB Weld. But that's my last choice. It's kind of a permanent solution. So let's try the shrink tubing first and resort to plan B if that doesn't work. Yeah, it's way too thick, unfortunately. So plan B it is. We'll use some JB Weld. That should do it. I'll just give that some time to cure. And when I bring it outside, I'm going to fill this tank right up to the top and make sure it doesn't leak. I've already got one of the circuit breakers relabeled to 25 amps, so I thought I'd just turn the camera on real quick for the other. Just using a label maker to make them, and then just trim the excess off and stick it on. I think the hardest part is just getting it straight. Can I get this without it going crooked. Good enough. I think we're ready to go. All the labeling has been corrected. The tank is topped off, and this is fully cured and the line reconnected. So it's a little windy outside. I'm not sure how much talking I'm going to do out there, but the plan is to get this started, let it warm up a bit, and double check the engine speed. It was a little slow, so most likely I'll bring that up to 61.5 Hertz. And then before load testing it, I'm going to try this meter out. This was lent to me by Ray, and it can measure total harmonic distortion. It shows it as a percentage on the screen. Utilities to your house, at least where I live, they are not allowed to provide over 5% total harmonic distortion. And a brushed generator like this with an AVR can produce up to 20% harmonic distortion. And that's what the box said on that stator. So I'm curious to see where we're at without a load. And then I'll put a 3,000 watt resistive load on it, which is kind of the best case scenario. It's not an inductive load, and just see how that harmonic distortion changes. So let's get this outside and see how it does. Yeah, not too bad. It started right up. The engine sounded good. The harmonic distortion without a load was around 5%. Put a 3,000 watt load on it, and things were doing well for a few seconds. The engine speed also actually came up a little to 61.5 Hertz, but after a few seconds it started to surge. So I think the carburetor might be starving for fuel. So I'm going to get this back inside real quick. We'll take a look, test the fuel flow, and see if there's an issue there. So I'm just going to pull this fuel line off and see if the problem is here. And in case you're wondering, the lift, it's in use for a more needy patient. So we'll just do this on the floor like the rest of this machine. All right, let's see what kind of flow we get. That's plenty. So I would say we have a carburetor issue. There is no issue with the tank or the petcock. It also backfired at shutdown. And there's a fuel solenoid on here, but this generator does not have the extra winding to power it. And a lot of generators don't have it and don't backfire. So I'm wondering if I should just swap the carburetor potentially. Yeah, I think I'll see what I have, but I think that's what I'm going to end up doing. I think I found one that is a good fit. It's more or less exactly what this needs. The only difference is that there is no fuel solenoid, and I think this is an OEM Honda carburetor. for a GX390. So I'm going to pause it here. We'll swap the carburetors out and we'll try this again. Yeah, that was a lot better. Figures, the one time I didn't clean the carburetor, and I probably should have, but that replacement carb ran the engine without issue. Under a 3,000 watt load, it held at 60.7 Hertz, 119 volts. And as far as the harmonic distortion goes, that spiked to about 19%. And that's a lot, considering this is only about a half load and a resistive load at that. It's only going to get worse if you're running an inductive load like an electric motor or a switch mode power supply. So keep that in mind if you're running sensitive electronics. Anything over 5% could damage them. Anyway, I think I'm done. You know, this turned out pretty well. I took 2 broken generators plus a new stator from Ryobi and made a nice Predator generator out of it. So this one, actually, I know who it's going to. Someone I know who needs a generator, so I will send him the link to the generator video so he knows exactly what he's getting. But yeah, I'd say he's getting a pretty good machine. So I hope this video helps someone. Thanks for watching. And I almost forgot, the rollover valve, no issues there. It stayed perfectly dry during the test, and with the tank that full, when rolling it around, this would have been submerged under gas and it had no issues at all. So I think we're good as far as that rollover valve goes.